Hello, today I'm going to take you through solving trig equations, and we're going to go through several examples. Let's look at our first one. And this is going to be 2 times the sine of x minus 1 equals 0. I want to solve this for x, and we're going to see that there are infinitely many solutions to this, but we're going to keep this between 0 and 2 pi, and you'll see, well, most of these are between 0 and 2 pi. Sometimes we'll change it up, though. All right, so the first step in solving a trig equation is to get the trig function by itself, or isolate that trig function. So to do that, you can almost treat it like when you had something like 2x minus 1 equals 0. Back in algebra class, if you're solving for x here, we're going to add 1 to both sides, get 2x equals 1, and then divide by 2, and you get x equals 1/2. So that's how we did it in algebra. We're going to get the sine of x by itself first here, using the same steps. We're going to add 1 to both sides and get 2 times the sine of x equals 1. Divide both sides by 2, and you get the sine of x equals 1/2. And the question here is, what value for x will make this a true statement? And so you can see there's going to be a whole bunch here, but we want it just between 0 and 2 pi. So you can think back to your unit circle, and we know that the y value is our sine value. So wherever sine is equal to 1/2, that's going to give me my answer. So there are 2 spots between 0 and 2 pi, and that's going to be pi over 6 and 5 pi over 6. And so this is my answer. If we look at the graph of sine of x, it looks like this right here in red. And I've went and drew also a horizontal line when y equals 1/2, and we can see there are many spots where the graph will cross a y value of 1/2. So I'm just highlighting a few here. But if you zoom out, you're going to see, well, it's not going to let me zoom out on the screen. Let's zoom out like this. There we go. You can see there's going to be a whole bunch there where it's crossing at 1/2. That's not what I want, though. I want it just between 0 and 2 pi. So here's our 2 spots right there at 5 pi over 6, and then the other one right there at pi over 6. And so those are our 2 spots between 0 and 2 pi where it works. And as we go through these, we'll keep most of them between 0 and 2 pi. Let's try out another one here. So here I've got sine of x plus the square root of 2 equals negative sine of x. So give that one a try. All right, I take it that you've paused the video and you've given it your best shot. Let's go through it together. Now what I want to do is get that trig function by itself. So to do that, I'm going to add sine of x on both sides. Just like in algebra, we would have gotten all the variables that we're solving for over on one side of the equation. So add sine of x to both sides. And that makes this just 0 on the right, and that equals the square root of 2 plus 2. I got 2 of these sines of x's now, so 2 times the sine of x. The next thing we do is move that square root of 2 over by subtracting it from both sides. So I get 2 sine x equals negative root 2, and then divide both sides by 2. So the sine of x is equal to the negative root 2 over 2. And so when is this true between 0 and 2 pi? Once again, if we just sketch out a unit circle, we know that sine is our y value. So when is it equal to negative root 2 over 2? It's going to be in 2 spots, right here at 5 pi over 4, and then again at 7 pi over 4 right here. So x equals 5 pi over 4, and x equals 7 pi over 4. All right, let's continue on. Try out this one. This one is 3 times the tangent squared minus 1. So solve for x here. All right, I take it that you've paused it and you've given it your best shot. Let's take a look and see if you got it right. So looking at this, this says 3 tan squared x minus 1 equals 0. Let's get that trig function by itself. So add 1 to both sides. I'm going to have 3 times the tangent squared of x equals 1. And then I'm going to divide both sides by 3. I get tangent squared of x equals 1/3. And then I'm going to square root both sides. So I get tangent squared of x. Remember, when I throw out a square root, I got to include the positive and the negative root here. So I get square root of 1/3. This is the same thing as square root of 1 over the square root of 3, which equals 1/√3. And rationalizing this, I get 3, the square root of 3 over 3. Now remember, this is plus or minus here from when I square rooted it. And so if you remember when we taught unit circle and we said tangent on the unit circle, you could think of it as the slope on the unit circle. So I want to know, when is the slope positive root 3 over 3 and when is it negative root 3 over 3? So looking at my unit circle here, there are 4 spots where that happens. It is the shallower of the slopes, so positive root 3 over 3 right here at pi over 6. And this line continues down here at 7 pi over 6. You also hit a slope of positive root 3 over 3. The negative one is going to be the shallow slope going downhill like this. So one right here at 5 pi over 6, and then another at 11 pi over 6. So if we're taking answers between 0 and 2 pi, there are 4 angles that make this work. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. X could be any of those. If you put them into this equation, the tan squared of that times 3 minus 1 would give you 0. All right, let's look at example 4 here. Pause the video and give example 4 a try. All right, I take it that you gave it your best shot. Let's see what we got here. So we've got cotangent times cosine squared times 2 times the cotangent of x. Now I'm going to start this one off just by moving over this 2 cotangent of x and see what we get here. So if you don't know where to begin on something like this, just start somewhere. And with experience of seeing, I know this one looks different than the other ones I gave you, but with some experience, you'll start to recognize different types of problems and know where to go with them. So just trust me and do lots of practice problems. So subtracting 2 times the cotangent of x from both sides, I get cotangent of x times the cosine squared of x minus 2 times the cotangent of x is equal to 0. Now I want you to look at this as one big binomial here. So I've got this mess, that's one term, minus this mess, that is another term. So I can actually factor out cotangent from this. If I factor out cotangent, write out cotangent of x, and I'm going to put inside the parentheses whatever I get when I factor it out. So I'm going to divide each term by the cotangent of x. If you don't understand what I'm saying, hang with me, and I think if you know your algebra, you'll get it. So cotangent times cosine squared divided by cotangent, these are going to cancel, and I'm left with just cosine squared. Minus, bring down that sign, the cotangent over cotangent, that cancels, and I'm left with just 2. So cotangent times cosine squared minus 2, this equals 0. I don't need this extra space here. I just left extra room in case I needed it. That's the same thing as what's written in blue up above. Notice if I were to distribute the cotangent, cotangent times this gives me this term, and then cotangent times negative 2 gives me that term. So I end up with cotangent times this mess equals 0. So I factored this. And so each factor I can set equal to 0, just like what we did in algebra. So I can say that the cotangent of x equals 0, and so does cosine squared minus 2 equals 0. Oh, don't forget the x right there. I'll take off if you don't do that, so I need to do the same. Make sure you put that x or theta, whatever it is, in there. So when is cotangent equal to 0? Let's go back to the unit circle and think about it. When tangent's undefined, cotangent equals 0. So tangent is undefined here at the top at pi over 2, and then again at the bottom at 3 pi over 2. So that would make this a true statement if we're going between 0 and 2 pi for our answers. So I can say x equals pi over 2 and x equals 3 pi over 2. Let's go over here and solve this. So add 2 to both sides. I get the cosine squared of x equals 2. And then I'm going to square root both sides, and I'm going to get the cosine of x is equal to the positive or negative root of 2. And so now we're going to think back to the unit circle and say, when is cosine equal to the square root of 2? Well, if you don't know what the square root of 2 is, you can pull out your calculator and say if I take square root of 2, what do I get? I get 1.41. I don't know if you can see that with that light there. There it is. The square root of 2 is 1.4. Well, my unit circle goes from -1 to 1 here, and -1 to 1 right here. Cosine is your x value. It never does reach 1.4. So there is no solution that makes this a true statement over here on the right side. So my answers stick with these two right here. Pi over 2 and 3 pi over 2. This doesn't give me any solutions there. Okay? Let's move on to the next one. So pause the video, give this one a try. And I take it that you've given it a try. Keep in mind something here. Remember, I'm giving you a couple different examples because when you do your own work, I want you to see it, what you could be seeing. So the last one we were able to factor. Even though there were different trig functions in there, we could factor it. Here, I'm having difficulty just trying to just flat out factor this one because you got cosine squared and then you've got sine. So whenever you see cosine squared, sine squared, tangent squared, any of the trig functions squared, always think back to your Pythagorean identities and think, can I use this to help me out here? So what can I substitute in for cosine squared into this equation? Well, if I go to this Pythagorean identity and subtract sine squared from both sides, this is what I end up getting. I'm going to say this is the same thing as 1 minus sine squared. Notice if I subtract sine squared from the left side, it goes away, but I also subtract it from the right side. So cosine squared equals 1 minus sine squared. And that's what I'm going to put into this right here. Where I had cosine squared, I'm going to substitute in 1 minus sine squared of x. And this is by our Pythagorean identity. And I'm going to multiply this by this number 2. Make sure you put it in parentheses or brackets so you don't forget you got to distribute the 2 to each one of those. So then I got minus sine x and minus 1, and this equals 0. Let's do a little algebra here and distribute the 2. So this gives me 2 times, or not times, but minus 2 sine squared minus sine of x minus 1, and this equals 0. And I'm going to combine some like terms. 2 and -1 give me positive 1. So I end up with negative 2 sine squared minus sine plus 1 equals 0. And notice that this is a quadratic. And here's where I'm going to do that little trick we did in a previous chapter. We're going to use U-Substitution to make this look a little bit easier to work with. So if I let u equal the sine of x, I can substitute u in for sine here. So this gives me negative 2u minus u plus 1 equals 0. And this looks a whole lot nicer to work with. I can factor this like I'm used to. So I want factors of negative 2 that add up to the middle term, negative 1. I've got 2 and 1. Let's let the 2 be negative. They multiply to give me negative 2. They add to give me negative 1. I cannot take the shortcut because the leading coefficient is not 1. So I'm going to break this up into negative 2u plus u and bring down the other terms. And then factor by grouping. This should be squared right here. So let's make that squared. And there is a negative 2u in common. This leaves me with u plus 1. And I'm just going to factor out a 1. I get u plus 1 right here. There is a u plus 1 in common. This is all basic factoring, so I'm just kind of moving through this quickly. You can watch one of my videos on factoring if you need help with that. And so these two things multiply to give me 0. Let's bring down that equals 0 there. So that means either u plus 1 equals 0 or negative 2u plus 1 equals 0. Solving for u, I get u equals negative 1. And then u is equal to what? Positive 1/2 right there. Now, I didn't ask you in the problem to ask, I didn't say what is u equal to. I said what is x equal to. So we need to go back and say I let u equal the sine of x. So now now that I got u solved for, I can put sine of x back in for it. So the sine of x equals negative 1, and then the sine of x equals 1/2. And I want to know what is the value of x here that makes this true. So thinking back to the unit circle, when sine is your y values, right here is -1 on the y value, and that happens at, 3 pi over 2. So x equals 3 pi over 2 is the only spot between 0 and 2 pi that makes sine -1. Also, we need to figure out when is it equal to 1/2. Well, that goes back to the first question we did on this, and that is at, pi over 6 and 5 pi over 6. Those two spots, your y value is positive 1/2, so we also have x equals pi over 6 and x equals 5 pi over 6 as a solution. So all three of those are values between 0 and 2 pi. That makes this a true statement. Now, this is just kind of like the tip of everything that we're going to be doing. There's plenty more problems like this, and some you might consider a little more difficult, but this was just an introduction to solving trig equations. I want you to see that you could use your properties of algebra that you've learned before to move things to one side of the equation or to factor stuff. And then you could also use your Pythagorean identities and your other identities dealing with trig to help you solve these equations. Please always take note of what I'm asking for. I'm asking between 0 and pi or 0 and 2 pi, or what we'll learn later, all possible solutions where we'll have to add multiples of pi to it. Okay? So I will come out with some more questions for you to practice with, so please do those. Let me know if you have any questions, and thanks for watching.